Hello, I'm Felipe Herrera, and this is my Physics 2211 Lab 1 constant velocity. So, a brief introduction. So, the purpose of this lab was to observe an object moving at a constant velocity using tracker and compare the movement of the experimental model to a predicted model made in GlowScript. So, for the calculations, we were assuming that there is no friction. It is a flat surface. There is only displacement on the x-axis and no air resistance. So some applied principles. Newton's first law, which is an object in motion will stay in motion until it is acted upon by an external force. Basically saying that my marker isn't being acted upon by any external force. And then here's the velocity formula and the position formula. So the experiment setup, what I did was I placed an expo marker on the table and just rolled it at a somewhat high velocity so that we could try to negate friction as much as possible in the calculations. And external factors include gravity, friction, and the applied force from the push. Here is the video from Tracker. So you can see I went frame by frame and clicked on the center of mass of the marker. And you can see the graph on the right. It produced somewhat linear results, which is very good. That means that we did a pretty good job in canceling out friction. So here are some findings from Tracker. So we set it to 5/4 frames per second, just so that it'd be easier to select the center of mass from the marker each frame. We set the initial position to be the vector 0, 0, 0, and the average velocity was 0.077 meters per second in the x, 0, and 0 in the y and z. So then here were the initial conditions for GlowScript. So basically I set the ball or the marker its mass to 0.202, the initial position to 0, 0, 0, and the initial velocity to 0.07700. Also set delta t to be 1.25, which is 5/4, so that we could try to match the time. Calculation loop. So I said while t is less than 13.33, which was the maximum time, or the total time that it was rolling, that the force net vector would be 0, 0, 0, because we were not counting for friction or any of that. So here we set up the ball's velocity and position formulas, and this is just so that it could appear on the next slide so that you could see the graph. So then here's the graph and what ran from the GlowScript code. So this, obviously, since it's a computational model, is entirely completely linear. So let's compare it to the observed. So here in blue is the computational model, and in red is the observed model. And because in real life there is friction and external forces that doesn't make the marker roll perfectly with a constant velocity, the position is less than that of the computational model, and you can actually see the difference get a little bit bigger towards the end. And some of these points that are like this one that's a bit higher, probably just human error. So follow-up questions. How would the data appear different if I flip the axis? So in my experiment, I set the direction the marker was rolling to be the positive x direction, thus flipping the axis would result in my marker rolling in the negative x direction. By flipping the x-axis, the marker would appear to be moving in the negative direction, resulting in a negative velocity and position. This, however, would not change my data much, as the time and magnitude of distance traveled remained the same. It would only make the slope of the graph downward. And another question, what do your observations mean, and can you calculate net force? In my experiment, it's not truly possible to determine the net forces acting on the marker. Due to the lab setup, I was trying to simulate an object with constant velocity. However, it was impossible to tell the force being applied by friction on the marker. So, thank you. That was my lab.